So I'm gonna moderate this panel, and I'm gonna actually let all of the panelists whom you've already met introduce themselves. So I'm gonna start with Dennis, and maybe you can tell us a little bit about how you got into formal demography and your background.
Sure. Okay. Great. So let's see. So when I was in college, I was very interested in computers, but ended up majoring in math. And then I finished college and decided I wanted to do some kind of work related to understanding why some countries were rich and some countries were poor. So I got a job as a research assistant with a group that did public health stuff. And that kind of was my first contact with demography. And I really liked that demography had this body of theory behind it, and that it also had a lot of ability to offer explanations for important real world problems. And I also kind of liked that it didn't rely on implausible models of behavior. So I went to graduate school eventually in demography, and I think in grad school, I'm not sure if I would have identified as a formal demographer in the first year or two, but I took a class actually in ecology. I went to grad school at Princeton, and I took a class in ecology that was taught by Simon Levin, who is a mathematical ecologist. I took the class because a friend of mine, actually John Palmer, who I think some of you may have encountered some of his work, and it's very interesting. And he had an undergrad degree in ecology, and we were kind of looking for interesting classes together, and this looked good, and I thought it was really cool. And really a lot of that class was formal demography, even though it was taught in an ecology department. And so then I kind of got, renewed my interest in the formal foundations of demography.
Great. Josh?
So did Dennis mention that he was a math major as an undergrad? So I was a history major as an undergrad, and I remember going to these history seminars, and the question would be, but have you read this? And I thought, can't they just talk about the thing that the seminar was about? So I found myself kind of accidentally in graduate school in France, and there I met one of the professors there was named Hervé Lebras, spelled, I guess, in French Lebras, but he likes to say Lebras because he's a proud person from Brittany. I know, so his background was very much mathematical, but I also know he knew a lot about everything. And so I kind of saw the idea of being a formal demographer and knowing a lot about all kinds of areas as it wasn't a substitute, it was a complement to these other things. And this also proved true when I began graduate school at Berkeley, where I met Ken and Ron, and I learned that Ron was a philosophy major, and that Ken, I'm not exactly sure what his official major was, but one of his majors was German literature in grad school. And I thought, here's an area where I can do, and I said the other formative thing for me is I read this book called Chaos by, was it by the journalist, what's his name? James Glick, which is all about the surprising things that simple models do. So I had always kind of had a little bit of math envy as a high school student, and I had a lot of failures in math in college. I tried to take some math, and it was always very hard. But I thought, maybe I could just learn a little bit, and I could see the world qualitatively in interesting ways. And so that's kind of how I got going. And I took Ken's course. It was very inspiring. I would say, which everyone in the world can now get a flavor of with his book, which goes from the most simple to quite advanced. It's kind of a modern survey. So I think that, and actually we just had Elizabeth speak, and I think she was came into demography from philosophy also. So I think there's, the first formal demographers often came from natural sciences and had super quantitative backgrounds. Somebody like Latka or not exactly Kiefertz or Cole, came from kind of more kind of drier subjects and they came into the more human subject of demography, but there's also a lot of reverse osmosis where people come from more human subjects into formal demography, and you don't need a lot of technique. You basically need the ability to ask interesting questions and have the faith that you can gain some insight with formal modeling and not be afraid to ask for help. I've had a lot of collaborators. And you saw this time, I didn't do any math in the slides. I made Maria do all the math. So I would just be very encouraging of people. And I thought that the last two talks were really great illustrations of this, where we had Ron. I think there's complicated things in the definitions he's doing, but conceptually what he's doing is not enormously complicated. It's just he thinks that the great kind of leap of faith there is that we can learn something by doing something that's simple, and we often get surprising things or see the magnitude of something that we only suspected about. We see something important that we thought wasn't important, or something that we thought was important was not important. And then with Elizabeth's talk, we saw the same thing. She's doing, of course, a lot of statistics, empirical analysis, and then they've got all these theories. And how does she bridge the two? Well, the simulation of saying, well, how is it even plausible? I mean, if we take values that we think of and simple model for how to combine those values, again, not the way the world really works, but to give us a sense of whether these values that we would need would be plausible, super neat, doesn't have to be super fancy. It just, without that, there's no answer to the question. And with that, there's an initial answer to the question. So I brought, the other show and tell thing I brought is I thought I would bring just some fun things for everybody to have on their bookshelf, virtual or otherwise. So I showed you Ken's book, which is, I think, a great overview of the whole field and also different ways of thinking about formal demography. The other thing I really recommend is to go back to the early papers. So these are papers identified by Nathan Kiefitz and Smith. Is it David Smith? Is the name right? Yes, David Smith. So these are classic papers from, of course, Latka, but also before and after. And this volume is now available for free. You can get it in a new version with a new introduction by two of my teachers, Ken Wachter and Hervé Lebras. So this is available free online. We'll put in links to all of these books. I had never read Latka before, and I did 2 or 3 years ago. This is actually a copy that I think I showed earlier in the day. But this is translated to English also. And what you get to see is how much Latka was able to do even in his first form. Well, this is not his first formulation. This is kind of the book he wrote 20 years after getting a lot of his ideas. So it's compiled together. But you get to see how he develops his stable population model, and then how especially he does all of these kind of first order approximations using Taylor series approximations, which I think he probably brought in from physics. And what I really appreciate about this book is I thought that Kiefitz was such a brilliant original mind, and I realized, no, yes, Kiefitz was brilliant and original, but also he had a great foundation. He had read Latka, and a lot of the stuff that Kiefitz did was just taking the same kind of thing that Latka did and just applying it to new problems, which is what most of us actually do. So we can also be Kiefitz. So I think the most fun and inspirational book that I've read over and over again is Kiefitz's second book. Well, it's probably his second big book. This is Applied Mathematical Demography. His first book, which I think called Introduction, is actually much more advanced. And I think, I'm sure since Ron and Ken probably think it's a great book because they read it before they read this. But for those of us who were born afterwards, this is a much easier book to start with. And in some sense, it's more inspiring because Kiefitz wrote things over and over again, and this is like his 16th iteration, and it's really well done. Now there's a newer edition with Hal Caswell, which again I don't know what it's like for a new book to start with. That it's kind of 2 books in one. It's all of this book plus everything done in kind of matrix formulations. I would say if you can do that, great. If that's too much for you, go get an older copy, and it might be easier than get both on. But they're both on my shelf. Okay, and then two other. Oh, here's the introduction to the mathematics of population that Kieferts wrote in the 1960s, which is, I think, a much more. It's not so much that the material is difficult. It's very difficult to understand the motivation of a lot of what he's getting deep into detail on. Whereas the applied mathematical demography, it's very good on the questions as well as the answers. And let me just bracket things with two other books. The first is by Mindel-Sheps and Jane Mencken. So Mindel-Sheps, she was a very important demographer of the 20th century, and the PAA's Formal Demography Award or Mathematical Demography Award is named after Mindel-Sheps and I believe Jane Mencken. I don't know if Jane Mencken was a student. Mindel-Sheps are just a collaborator, but they're two different generations. And so this book is all about the formal demography of conception and things like birth intervals, applying renewal theory and ideas from renewal theory on the kind of question that I think I raised earlier, which is that if someone didn't get an abortion, how many more kids would they have? Well, there's a kind of a social answer to that in terms of their targets, but there's also kind of a biological answer and a statistical answer to that. And so that's the kind of inspiration for that. And then the last book that I refer to quite a bit now is a newer overview of developments in the field, probably the last 20 years. This is a book by Robert Schoen called Dynamic Population Models. And it has, it's really beyond stable population theory. It starts with a chapter on stable population theory, and then it has lots of work by Schoen, but also by others, kind of showing how changing rates. That's the common theme of this book, and it's very comprehensive. The text is comprehensive. It reads like a textbook. It takes you from the beginning to the end of it. But the material is rather idiosyncratic. It's Bob Schoen what he thought was important, and a lot of these issues. It's basically issues that he did some work on, and then he fleshes out the literature on it. But that's a really nice book. It looks exactly like another book, the edited volume, which I think I cited earlier, where Tom and I have a chapter. Same color, almost the same words in the title, but that's like an edited volume, and this is Bob Schoen's own volume. So those are all fun books, and we'll put them on the reading list.
Wonderful. Thank you, Josh. We'll make sure to type out the names of these books somewhere and post so you can refer to them. Okay, so I'll introduce myself a little bit, and then we'll turn to the great set of questions that you all have submitted. So I guess I haven't actually formally introduced myself to this group since I didn't teach, but I'm Ayesha Mahmud. I'm an assistant professor in the department, and my background, my undergrad was in physics and economics, and I wasn't really thinking much about demography. I was pretty convinced that I would do graduate school in physics, and so I spent my summers in grad school working. I especially was interested in astrophysics. I think looking back now, partly because my older brother, who I wanted to be like all the time, is an astrophysicist and was doing his PhD in astrophysics at the time. And I was just like, my whole life, I wanted to be like him. And so, I spent my summers, I worked for folks who run the Hubble Space Telescope. I did a lot of work with Hubble data and all sorts of things related to how stars form, and completely unrelated to demography. And then I even took the physics GRE and, was going to fill out applications for grad school. And then I think probably at the age of 21, I decided I just couldn't pursue this dream to be like my brother all the time. And so I would try and do something else. And so I went and worked for what at the time used to be called the National Opinion Research Center. It's now just an acronym. It's NORC. They do survey research. And I just got very interested in sort of health and initially health economics, because I had a little bit of background in economics. And we did a lot of work on looking at Medicare and Medicaid populations. And so we did a lot of work for the government trying to understand various questions that they had about their Medicare and Medicaid program. And then I went and worked for a health economist for a year at the National Bureau of Economic Research. And he was doing some really interesting work. This is Jonathan Gruber at NBER, and he was doing some really interesting work designing what became eventually the Affordable Care Act. So that was also sort of, really interesting. But I came out of this period in my life not really knowing what I wanted to do, other than I think I wanted to do a PhD, but I didn't know in what. And I think I didn't have very strong ideas of what field I wanted to do. Maybe similar to Josh, I think I also read Chaos at a later point in my life, but was interested in models and math, and kind of wanted to be in a field that used that. And I should say that demography was not new to me. My mom was a demographer, and she was a great friend
Confession. Now we're hearing this.
I wondered if we were going to mention that.
I know, I know. She was a great friend, for example, of Jane Mencken, who Josh mentioned. So Jane came to Bangladesh many times. I met her, and all the sort of demographers who worked in Bangladesh, Stan Becker, Randall Kuhn. I'd met them very early in my life, when I was like a child. And my mom was William Bress's student, and he had visited Bangladesh many times long before I was born, when my mom was his student, and he stayed in the same house that I happened to later grow up in. So I had this connection with demography, but in my childhood, it was very much a thing that my parents did, and these names didn't mean anything to me. But I did apply to a demography program, but mostly I was applying to econ and public health and health policy programs. But I really liked the demography program at Princeton where I went, which is the same program as Dennis, and I just decided to go, and that's sort of what led me into demography. I took a lot of classes in ecology, similar to Dennis, and my two main advisors ended up being in ecology, and I'll talk maybe in a few minutes about sort of links of demography with other fields, and I think there's a lot of historical links between ecologists and demographers. But that's sort of how I ended up in demography, and I guess I never have thought of myself as a formal demographer, and I'm not sure I think of myself as a formal demographer even now, but that's sort of, I do teach the methods class here, so I'm starting to feel a little more like a formal demographer, but that's, I guess, been my path into demography. Okay, so I'm going to try my very best to synthesize all the great questions that you have submitted. If there's additional questions, like burning questions that come up, you could put them into chat now, and if we get to them, we'll try to. But I'm going to pose some questions for Dennis, Josh, and myself, sort of synthesizing the things that you've all mentioned. So one of the first, or a group of people asked about, thinking about, some of the most important, I don't know if discovery is the right word, but just, discoveries in formal demography over the last decades, and also thinking about the future of formal demography and the question of where formal demography might be going. But let's start with the first question, and maybe I'll turn back to Josh and ask him about his thoughts on maybe a few of the most important.
Okay, first of all, thank you for all the great questions. We got them, and I was looking at them last night, overwhelmed. There's so many good questions. We could spend a whole hour on, I think, probably 20 or 30 of these different questions. So I thought, oh no, what are we going to do? And I wrote, Ayesha, can I write on this my top three recent works? And she said, oh, but that's public. So I wrote an email, and I'll tell you what I wrote. I wrote down, this was just my kind of off the cuff answer, and maybe we'll have a discussion, and I'll learn that they're the wrong things or something. And this is also what I've been influenced by and the things I've worked around. So I would say the most common thing that demographers know that non-demographers don't know for the last 20 or 30 years is this idea of tempo effects. And so this Baumgart's and Feehan paper, I think it's 1999. Not a new idea in demography, been around for many decades, but they applied it to a particular question, which was this low fertility we're seeing around the world. Is this because women are having few children? And they showed that actually they had a simple model for showing how postponement affects period rates, actually they had a new model of period postponement, whereas Ryder just had cohort postponement, but it's the same general idea. And I suppose, like a lot of good papers, it immediately received kind of very negative responses. There are a bunch of responses to the paper, and that's kind of a good sign, I guess. And then they wrote back. But that's really, I think, an important kind of conceptual idea that paper really produced a lot of discussion and really distinguishes, I think, demographic analysis of low fertility from, say, the analysis of low fertility done by other disciplines. And the reason is because it is at the interface of how individual behavior is not necessarily summed up to give you what you see for a population. It's an aggregation issue that I think maybe Elizabeth mentioned earlier. So my second one was not a discovery, but rather a database, and that's the human mortality database. So I didn't bring any of Kiefertz and Flieger's old books, but Kiefertz and Flieger have wonderful books full of data, which were, and also the cold domain life tables, which is what demographers used to use. But since the human mortality database, which was founded by John Wilmoth, who also was on the faculty here at Berkeley and now runs the UN population division. And it's now a joint project of Berkeley and Max Planck. Here at Berkeley, it's run by the co-director, Magali Barbieri. But this database has really literally launched thousands of papers, and I think it's given formal demographers kind of the ability to find these stylized facts that they need to explain with models. So the whole study of heterogeneity is helped by, ironically, this aggregate data that doesn't have any breakdowns, but all the things that you've heard recently about E-Dagger, and we didn't do mortality forecasting, but a lot of the mortality forecasting, limits to old age, and it hasn't been used that much in the study of inequality, but it can be. But I think that the idea of creating these open source databases is also, the human mortality database launched 1,000 other databases in some sense. When I was at Max Planck, we started the human fertility database, just copying the model of the human mortality database. And I hope more things like, and I guess NTA, which is a totally different project, but in some ways the idea of that, if share it and they will come, that philosophy was started. And then the third thing I thought of was a paper that we do in economic demography by Ron and many of the same co-authors that he mentioned. And it's a science paper showing that the optimum fertility rate is not necessarily zero growth rate, but a little bit negative growth rate is actually can be optimal. And again, the framework is just very elegant and simple. It provides, I think, a super important perspective, which is that we shouldn't necessarily be scared of aging. There's such a thing probably as too much aging. There's also such a thing as too little aging, and there's probably there's probably something just right in it. But that's, I think, a very, I could have chosen any of Ron's papers, but that's the one that kind of struck me as kind of in some ways easy to understand what the contribution is. So when I kind of summed all this up, I thought, what do these things have in common? The two things came up. One was that a lot of today's contributions are grounded in previous work. They're old ideas that just kind of came together. So that would be, a classic example would be Ryder and his influence on Baumgart's and Feehan. And the second is, I think maybe related to some of the other questions, the availability of data is what's doing a lot of this. It's kind of this marriage of data and formal thinking. It's not statistical thinking, which is also needed for analyzing the data, but it's like the models that inspire the use of the data, inspire which measures are useful. And so for Ron, that would be the NTA data, which they're also collecting themselves. But for a lot of the formal demographers working in mortality, it's the HMD data or fertility, the HFD data. So that's what I wrote in my email.
Dennis, you've thoughts on that, or maybe thoughts about, maybe looking forward and.
Yeah, I mean, I think that's an excellent answer. I would say looking forward, I think there's a couple of areas that are really exciting for formal demographers and demographers more general. I think somebody mentioned in one of the other questions this idea of big data, so maybe we'll talk about that in a moment, but there's clearly a sort of scale and type of data that's becoming available to many demographers that has a lot of potential, and I think really needs something like formal demography to help make use of it. And then the other thing would be this is not incredibly new, but there's increasingly genetic information associated with a lot of demographic data sets, and there's a lot of interesting ways that those genetic information could be understood using tools like formal demography and population genetics, and formal demography also has a lot of overlap. So that's another exciting area. It's a hard area to. That one in particular, you kind of need to learn a lot, I think, to do a good job of working in that area, because there's a lot of biology to be understood in order to do a good job of posing good questions and answering them well. But as Josh kind of alluded to earlier, one of the really cool things about being a demographer is that there's just constantly opportunities to learn from other disciplines. It's not the kind of thing where there's a silo that you're always in. You always have a chance to learn something that some other field can teach you. So,
Great.
What do you think?
Yeah, I think that's actually a nice segue to, we have a whole host of questions about people interest in other fields and collaborating with other fields and learning tools. And I think genetics is going to be increasingly more important. But I think to Dennis's point, there is a steep learning curve, and I think there's at least in my opinion, hasn't been enough effort in pop centers and demography departments to bring in some of those teaching material or courses or expertise. I'm thinking of, there's not, I think, been a lot of work in sort of the field of population and environment, and then thinking about climate change, not a lot of formal demographic work. And I think part of that is, again, there's a steep learning curve to sort of learn about these climate models and even the different sources of climate data and the biases in that, I think requires a level of training that we don't typically offer in our demography departments. You often have to take sort of self-initiative to seek that out elsewhere. So I think there's probably more that we can do to try and incorporate tools and methods from those fields into our sort of curriculum and teaching. I also wanted to mention sort of thinking about historical links with other fields. Dennis already mentioned this, the link with ecology, but there's lots of really great examples, and Elizabeth actually talked about demographers working with evolutionary biologists in her talk, but there's sort of really great examples of where demographers and ecologists have worked closely to come up with even very relevant policy questions. So one example I was thinking about this morning when I was thinking about this question is ecologists and demographers have known sort of very early on from some demographic, and it's sort of a mixture of demographic and disease transmission models, this concept of what they call the rubella paradox. So I'm going to summarize it in just a few sentences, because I think it kind of highlights a way that demography can integrate with another field and have a very relevant policy application. So rubella is this childhood disease that before there was a vaccine, almost everyone would get it. If you've been born in the 1980s, or you're born in the US, you've probably had the what they call the MMR vaccine in your childhood, right? And so you're vaccinated, you're protected against rubella. In many countries in the world, they intentionally don't vaccinate children for rubella. And this is entirely due to this discovery by sort of folks working at the intersection of ecology and demography, is that there's this interesting sort of paradox where if you don't vaccinate enough children for rubella, you start a program but you don't vaccinate enough children, what you end up doing is you end up increasing the mean age of when you get rubella. So this makes sense. It's a more rare disease. You just get rubella later in life. Instead of everyone getting it at the age of 2, maybe you get it at the age of 10, maybe you get it at the age of 12, because some proportion of the population is immune. And the sort of scary part of that is that rubella is not a dangerous disease if you get it in childhood, but if you get it and you're pregnant, it has very, very, very serious consequences for the fetus. And so Zika is an example of another disease that causes this, but the rubellas, the consequences for the fetus are much more dire, often leading to miscarriage or stillbirth. And so this discovery by governments led to this discovery, by demographers and ecologists led to governments actively changing their policy and deciding to keep rubella out of their vaccination. So when I was growing up in Bangladesh, you couldn't get the rubella vaccine because they didn't think they could achieve enough vaccination coverage to stop this large increase in the burden of stillbirths and miscarriages. And there's a great team of demographers and ecologists working together right now, actively designing these models where they combine this rubella transmission, these classic SIR models, with demographic models where they bring in fertility and projections of births to try and inform governments whether they should, when is the right time to introduce vaccination for rubella. So it's a sort of very concrete example. I'm thinking of Amy Winter is a demographer that Dennis and I know, but she's written tons on this topic, and she's at University of Georgia now, and you can go look up this work. But I just wanted to highlight this example of something where, there's this link that has existed for a long time, and there's still a lot of, I think, ecologists who consider themselves demographers, and many pop centers actually combined ecologists and demographers under one roof. So I think University of Washington still calls it the Center of Ecology and Demography. I think Wisconsin might also do the same, and there's a lot of sort of interesting overlaps. And I'll just give one more example. Again, a personal story, but my sister-in-law is a plant biologist, but she calls herself a plant demographer, and she studies gender expression and sex expression in plants. And she's been working on developing all these interesting demographic tools for studying the fluidity of sex expression in plants. And this is, again, just another example of where there's folks in other fields developing a lot of interesting demographic tools that could potentially have applications in things that we think about. So I think that the thinking about how to make these connections stronger is something that we should probably all strive to do. Josh and Dennis have thoughts.
Maybe just listening to you, I thought of why don't we collaborate more? And I'll just give you two obstacles that I've encountered. So in the formal demography realm, I work with my old friend and my collaborator, Tom Cassidy, who's a mathematician. He's a professional mathematician. And the constant discussion we have is he just feels lost because he doesn't know what I'm trying to produce. He's like, we have the proof, it's true. I said, well, yeah, but we need something that's going to provide insight. I said, he says, we have the exact answer. I said, but the exact answer, I look at that, I don't understand it. I want something simple. It doesn't even have to be as accurate. So it's kind of the thing I'm looking for is really because of the culture of demography, and I know it's going to be appealing to demographic readers if we have something simple. It doesn't have to be exact. It has to be simple and give insight. And for someone who's not in the field, that's just very hard to kind of know what we're getting at. And then I think from the opposite direction, I think demographers have something to contribute, but a lot of fields don't think this is the case and think they can do it themselves. And this is obviously a very difficult situation to enter into. When you as a demographer, you probably have less substantive understanding of what they're doing. Your first few conversations are not going to exactly inspire confidence in them. So it's not easy, and I think it's probably not a coincidence that a lot of collaborations don't happen kind of through purely scientific mechanisms, but through conferences and workshops, and people meet each other, and there's the social network of this is very important for collaboration. And it's also probably, to go back to what maybe Elizabeth was saying about the demography profession yesterday in publishing, it's important to keep our journals like Population Development Review and these journals that have historically been very open to lots of different perspectives, very open. Otherwise, we'll lose outlets for collaborative research. I think we could ask Ron about trying to publish economic demography in purely economic journals. It's hard, even as a economist hat wearing person, which Ron also is. So that's just it's not always easy.
Okay.
Is Ron listening? I don't know if he wants to chime in. I'm mentioning his name, but he's not here.
Well, Dennis, you mentioned sort of formal demography in the era of big data. Do you want to?
Sure. Yeah, I can say it a little bit. I think Josh has too. Yeah, I think maybe formal demography or theory more generally is super important in the context of big data, and I think I think sometimes you hear a line of thinking that says we're going to have all these data, we don't really need theory because we can just directly answer any question we have with the data, and I think I don't think that's true. I think having more data allows us to push our theories a lot farther and to hopefully learn more. But anytime you do anything with data, you're using theory quite a bit, and so I think the era of big data offers huge opportunities for any body of theory, including formal demography. It gives us the opportunity to potentially really test a lot of assumptions that underlie theories that have been previously untestable. And then I think maybe most importantly, the availability of new data should help us generate new theories, which we can then explore formally. So I guess this is sort of a debate you hear often in the big data world, sort of what is this the end of theory, or do we need theory? And I'm firmly in the we really need theory.
Yeah, I mean, I think the basic message we've been trying to preach here, to the extent we've been preaching, is that formal demography is not an end in and of itself. It's part of thinking through a problem, and thinking through a problem involves some modeling, it involves some observations, it involves trying to put them together. So I think the easy answer to this is, of course not. But big data just makes formal modeling all the more important. I thought, well, can I think of a yes answer to this? Can I think of a no answer to this? And I think I thought of a yes answer and a no answer from things that I'm familiar with. So much like in the example we had with Elizabeth just now, where she's kind of looking at an empirical problem with some where the data doesn't necessarily match up to testing the hypotheses, you model kind of in between. I've been doing a paper on fertility, and the idea was, this is using microcensus data, the idea was maybe we can see whether people are trying to have a lot or a few children by looking at the names they give their children. Maybe there are high fertility names, low fertility names, and when people have their first child, we can figure it out. This is historical times. And so we didn't know which names were going to be high fertility names and which names were going to be low fertility names, so we just kind of did it empirically. And we saw, oh wow, there's all these low fertility names. Well, then we thought about it a little more, and the measure of fertility was how many children did you have in the household? And that was very much determined by the age of the oldest child. If your oldest child was 3, you couldn't have many children in the household. If your oldest child was 13, you could have more children in the household. So it turned out what a lot of our names were picking up was kind of the stable population effect, that in a fast growing population, you'll have a young average age. You'll have kind of a pyramid like this of the fraction of people with that name. And so the new names, the ones that were getting really popular, were on average held by oldest children who were very young, and the less popular names will be. So in other words, it had nothing to do with achieved fertility. It was just a measurement kind of thing. And having demographers on the project made us realize that, made us kind of change direction. So that's an example of, we have all this data, we're kind of using brute force mechanisms to identify which things predict what, and then the data generating mechanism in some sense was demographic, and so we were able to understand the data generating mechanism using formal demography. So that's an answer for yes, why we need models with big data. And then I think there's also kind of a no example. So one of our grad students here, Casey Breen, who's also been an assistant in past formal demography workshops, has a chapter in his dissertation where he looks at the black-white crossover in mortality. So this is the phenomenon that at young ages, black mortality is higher than white mortality, and at older ages, actually white mortality is higher than black mortality. So there's this crossover of the hazard curves. And there's a long debate on what the cause of this is. The favorite formal demographic explanation is, oh, there's selection, which I think we just maybe even saw from Maddie's question, a little bit similar to that, that to make it to an old age as as a black person is harder than to make it to an old age as a white person. So you carry it, you're just kind of a tougher, more healthy person. The average survivor is age 90. And then there's a lot of discussion about how this is an artifact of measurement, and there's age misreporting, and the data is missing, and so actually the stylized fact isn't even a fact. There's that discussion. But now that we have more data, we can actually look at the characteristics. Like we have big microdata. We can look at the characteristics of people who die at different ages, and the cohort as it ages. We can look at their education and their income and their occupation and all kinds of details, their height, all this kind of stuff. And that's what Casey's able to do. And he finds, lo and behold, with all this new data, you can see very clearly that there's no crossover when you say control for education. There's only a crossover when you don't control for education. So if you look within an educational group, the hazards are kind of parallel. It's that the composition of the educational groups changes over time. So why does this mean big data doesn't mean formal modeling? I would say the formal modeling was not able to answer the question before. And now that we have the data, we can just see directly there's not really a paradox that we thought there was, or at least that's what Casey's arguing, or my maybe overstated version of his conclusions. What's the analogy to this? Maybe this is an analogy like a telescope analogy. You had Einstein, general relativity. I think there was an eclipse, and they had to get a picture of the eclipse. Am I saying this right? And so you can say, well, once we had the picture of the eclipse, we didn't need this whole theory. But on the other hand, we wouldn't have even taken the picture of the eclipse if we didn't have the theory. So in the same way, I don't think Casey would have even done his analysis if we hadn't had this whole formal explanation for how frailty might work, heterogeneous selection because of frailty. And so I think big data is going to answer questions that were purely in the realm of theory, but that is somehow they're still tied to the theory because they're inspired by the theory.
Thank you, Josh. So I think we should actually stop because we're very close to noon, and we're going to do a little bit of a wrap up and some folks
Super.
before we end.
Yes, that's
All
a
right.
great idea.
Great.
So let's give the panel applause.